Hi, it's Bruce Rouse here, and today I want to talk about LED lighting and pose the question is, after the LED revolution, is it still cost effective to do lighting upgrades? Now, what do I mean by this? Well, LEDs kind of emerged as they've been around since the 1950s or 1960s. I remember when I was a kid, I had a little science kit which had LEDs in it, colored LEDs. But from around about 2005, perhaps that was the earliest, maybe 2006, um, we started to get LEDs emerging as lights that could be used to replace lighting in buildings. And I first began involved with this in 2008, where I actually won a state government contract to do some research into LEDs as a fluorescent lighting replacement. This involved desktop research. Then it involved purchasing LEDs from a variety of brands. I think we bought maybe 7 or 8 different brands of LEDs as fluorescent tube replacements. And then we ran testing of these LEDs, some lab testing we built, where we actually tested their actual performance versus the manufacturing claims. And then finally, we installed these into the selected LED into a building and measured the lux levels. It was a community facility. And so that was back in 2008. And back then, the price per LED tube, I think we were paying around about $100 per tube, very expensive. This was, of course, was government subsidized to kind of write a case study, and the cost benefit wasn't that good. But we did get high efficacy LEDs. We bought the most efficient we could. That was why the cost was so high. And we got good energy savings. Now, since then, LEDs have just gone from strength to strength. And I'd kind of say the LED revolution is over now, because if you're going to buy new lights, they're going to be LED. And many buildings, most buildings now, I think, have replaced their legacy lights with LED. Look, there'll still be a few fluorescents around and compact fluorescents and maybe even some halogen lights still around in commercial buildings. And there's still high pressure sodium around, some metal halide, very little mercury vapor now available in more industrial lighting, but more and more we're seeing LEDs just, well, not more and more now. Now it's just the de facto standard, and so we've gone from a huge efficiency improvement. A standard LED now, so-called standard LED, has around about 100 lumens per watt. Now, the problem is that that standard hasn't really moved much over the last 5 years. It's about 100 lumens per watt 5 years ago. It's about 100 lumens per watt now. Um, and 100 lumens per watt as a standard LED basically means that with a fluorescent tube, because the LED is also directional, whereas a fluorescent tube is many directions, in a well-designed fitting, you can roughly halve the energy use. May not quite be that much, but then you can also get a slightly more efficient LED, say maybe 130 lumens per watt, and definitely halve the energy usage. If you go even higher, and I think now you can get around about 160 lumen per watt, maybe even more than that, fluorescent kind of LED replacement, then perhaps we're talking about savings of say 60% compared with a fluorescent light fixture. So typically, if we looked at say the standard kind of light fixture here in Australia was a 36 watt twin batten, or twin two tubes, each 36 watts. They often had an iron core ballast, which might use another 5 watts. So we're looking at a fixture of about 82 watts. We had T5, which was 5/8 of an inch diameter, versus the traditional T8, 8/8 of an inch diameter tube. They had slightly more efficacy and had electronic ballast, therefore at a higher frequency. Um, their ballast consumed less energy. But even so, we're looking at approximately 80 watts per fixture. And nowadays, you'll probably get a fixture, or many fluorescent lights have been faced with fixtures that use half that energy, 40 watts, or maybe a bit less, maybe slightly more, depending on when it was replaced. So 40 watts, it's a halving of energy use. And that was cost effective. It's been a big revolution. So looking forward, my question is, are we going to get another revolution like that? Because that's amazing. We've been able to basically halve the lighting energy use of buildings across the world due to LEDs over the last 15 to 20 years. That's amazing. Can we get another halving is the question I want to look at. And will it be as cost effective? Well, on the face of it, it won't be as cost effective because, if I went from 80 watts to 40 watts, but then going from 40 to 20 watts, well, it's only half the energy savings. So even though it's another halving, so half the energy savings means for the same cost, the payback is twice as long. So this is the question I'm trying to pose now. But I think that I'm going to answer yes, a qualified yes. The LED, there can be a second wave. And my prediction is that that second wave, um, well, it's a bit hard to predict, but I would estimate that this second wave is probably, well, it's already here to some extent. Look, if I really look hard, I can get very, very high um, efficiency LED tubes as a fluorescent tube replacement, or a complete fixture, which is perhaps a little bit more elegant, but in some ways, but not in other ways, which I'll come back to. Um, I can probably get 160 lumens per watt now, which, is pretty good. I could go from a 40 watt maybe down to a 30 watt fixture now, uh, LED, which was previously 80 watts with fluorescent. So that's good, but will that continue? Well, a bit of research indicates that uh, perhaps by 2030, we're going to have LEDs in the range. This is the high end of efficiency of a range of 180 to 220 lumens per watt. And I would guess that, you know, perhaps by 2030, the mainstream standard efficiency may have gone from the 100 or so that it's been for the last quite a while now, perhaps up to 120, 130. And then by 2035, maybe you would be looking at a standard LED efficiency of around about 150 and a premium maybe 230, 250. So from 100 kind of the standard now to 250 in 2035 lumens per watt, that's 40% less energy for the same lumens. That's actually getting pretty good, and I think um, so 60% less energy. That's showing that this LED revolution can continue, but it's going to happen at a slower pace. So um, it is still cost effective to do lighting upgrades, but you've got to do a fair bit of research. Um, the good thing is that these very high efficiency LEDs now are way cheaper than they used to be. Um, we're maybe talking $20 a tube now. And I keep talking about tubes, and I'll come back to that versus whole fixtures. And we're also getting emerging features which have actually been around for a while, but perhaps are going to go more mainstream, which is inbuilt sensors in the lights for occupancy, um, perhaps some daylighting, although daylighting sensing is pretty hard to do effectively because you don't want to get confused with the light coming out of the fixture versus the daylight. And we're seeing this in car parks for a while. There's a great Australian project around, and I still see their lights around, um, which networked the lights in a car park with sensors. And we're getting savings of 80 to 90% when you replace standard fluorescent lights in a car park that are on all the time with these LEDs with these inbuilt sensing. So with, over half the savings coming from the sensing, the lights just go off when there's no one there, and then they come back on when a car appears or a person appears. And then they were networked, so one would go on, and the rest near that light would go on as well, which is kind of smart. So I think that trend is going to continue. So we're going to continue to see smart applications, but again, it's going to require a little bit more engineering um, and a little less kind of off the shelf. So this then comes to the role of energy advisors being staying informed of the developments, knowing which brands they can recommend, and so on. So let's just talk about, I want to come back to this discussion about LED tubes versus whole fixtures. Now, the issue with replacing the whole fixture is that when the fixture fails or the lights fail, and often LED fails, they start to flicker. They'll flicker on and off at an annoying frequency. And that's when you know that there's something wrong with the driver and it's failed. Or gradually that's a bad quality driver, and the driver is a key element of LED. That's the power supply that regulates the power supply to the solid state device that emits the light. Um, of course, then the other failure mode is the light just gradually gets dimmer, although LEDs do lose their brightness pretty slowly. Um, but the problem is when a fixture fails, you've got to replace the whole fixture. Um, so that is problematic for several reasons. Firstly, there's the cost of replacing the whole fixture. Basically, you've got to buy a new fixture, and you need an electrician because it's using you're cutting into an electrical circuit there. That you have to disconnect wires, reconnect wires. That needs an electrician to do. So there's the materials cost, and then there's the labor cost, which is going to be higher than just replacing a tube. The second aspect, I guess, is coming from a life cycle aspect. What's going to happen when replacing all these old fixtures? Um, you know, uh, 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 how does it get recycled? These are posing questions around life cycle analysis. So to one extent, I think the LED revolution's been fantastic from an energy efficiency perspective, but from a life cycle analysis, perhaps it hasn't been so good when when you have to replace an entire fixture, not just the tube. So typically with, say, a fluorescent fixture, which I'm highly familiar with, you have what at the end, what you call lamp holders, which are called tombstones. Tombstone's another name for them. Um, so what happens is fluorescent lights produce a lot of UV lights, and eventually those tombstones will become brittle and break. And an electrician could either replace the tombstones, but that was kind of a bit of a task, requiring an electrician, or you'd replace the whole fixture. Um, but you may get perhaps a 40-year life, 30 to 40-year life, depends on the hours of operation. And this is a bit of a guess from a fluorescent batten. Um, I think LEDs probably produce less UV, so that could maybe be 50 years. And a quite common upgrade is just to rewire the fixture. You've got to bypass the power supply, um, bypass the starter, and basically you rewire the fitting, and then which requires an electrician, and then put in an LED tube. The advantage of that is when that LED tube fails and the LED tube's got an inbuilt driver, you just replace the LED tube. And that means you can continue to use a fixture. And I suspect that those fixtures will probably last 50 years, possibly 40 to 50 years. And it's a bit of a guess. And all you're replacing is a tube. Um, so, but is this a real concern? So we have with LED lights, manufacturers claim 35 to 50,000 hours life. In reality, evidence seems to point that perhaps 25 to 40,000 is more realistic lifetime. So for an office building, 25,000 hours is maybe 10 to 12 um, years of operation. Sorry, maybe 12 years of operation before you need to replace that light. So if we compare that, if that was a whole fixture, perhaps you'd replace that fixture 3 times before we had to replace a fluorescent fixture. So actually is a bit of a big deal. So I would think that I'm hoping, and I hope this emerges to be a trend, that we are moving towards LED lights where we look at the life cycle as well. And you put in some sort of fixture, whether it looks like a fluorescent fixture or not, with the tombstones, maybe something completely different. Maybe there's a new standard going to emerge. I'm not quite sure. And then you just replace the light within the existing fixture as a way of preserving the life cycle, extending the life cycle of that, better for the environment, less materials wastage, and also lowering the cost of the LED upgrade. So that's a possible thing, and you just focus on providing the power. Now the two elements of a LED fixture are the power supply and the light source, and then there's the housing. 3 elements, I guess. The thing that may fail first is the power supply, and often in these, that's often why LEDs are now sold as entire fixtures is because of the power supply being inbuilt into the fixture, and not into the lamp. So this is something that I think is going to be an emerging trend that those energy efficiency advisors should be really trying to understand, the possibilities to not look at just at the energy savings, but at the life cycle impact of upgrades to LED. So I guess to summarize this bit of discussion about LED lights, I asked the question, is after the LED revolution, is it still cost effective to do lighting upgrades? Let's just add a few more points on that. I think yes, because LED lights will continue to improve. And over the lifespan, let's say it's 12 years in a commercial setting, maybe 12 to 15 years of an LED. Over that 15-year period, um, LED lights will have probably improved quite a lot. Certainly now through to 2040, I can see improvements. Perhaps it's going to taper off there as we get, the rate of improvement starts to slow. But for now, I think we're seeing still fairly steady rates of improvement of LED lights. Perhaps it is slowing a little bit. Perhaps the curve's a little bit flattening out of it, but it's still improving. So yes, it will still be cost effective. One of the challenges though is the cost of the fixture. And so I'm hoping that there's going to be more innovation around reducing the cost of the fixture so you can just replace the light. This is not in the interest of the lighting suppliers, by the way, who I think are probably pushing fixture replacements rather than lamp replacements, because they're selling a lot less lamps than they used to if the life is 3 times longer. And then the second area that makes them cost effective is the incorporation of sensors and smart controls. And yeah, there's just one more thing: the light quality. Some high-end fixtures becoming adaptable in terms of the light color to kind of align with your body's circadian rhythms and similar, so the light color is appropriate, and you're not getting this problem with blue light that's a well-known problem with LEDs, as affecting possible sleep cycles. So yeah, I hope you've understood from this that LEDs, it sounds pretty simple, but there's quite a bit involved. However, I still do believe that there's opportunities. It is still cost effective to do lighting upgrades with LED, from LED to better LED. Perhaps not quite as cost effective as it was with things, but if there's opportunity for energy efficiency advisors to apply engineering knowledge to design, just take careful selection, product specification, and I guess optimizing the benefits, and there will still be a continued role for energy efficiency advisors to build the business case using their expertise to come up with tailored solutions for their clients. It's just going to be a little bit harder than it was before. So thanks for that. I hope you found this useful. Thank you.